this video, we will talking about application of sampling in industry and agriculture based on Chapter 4 Chemistry 256.
Before we start, let me introduce our group members, which is Shaira and Danish. Sampling. What is sampling? Sampling is a process in statistical analysis where researchers take a predetermined number of observations from a larger population. Sampling allows researchers to conduct studies about a large group by using a small portion of the population. The method of sampling depends on the type of analysis being performed, but it may include simple random sampling or systematic sampling.
So let's see the material that can be sampled. First we have air sampling, solid sampling, and liquid sampling. But in this video, we more focus on solid and liquid sampling. What is solid sampling? Solid sampling is inhomogeneity material. It is one of the most difficult sampling techniques. Grad sample, which are one sample taken at random and taken to be representative, are the easiest but typically inaccurate way to sample a solid material. Gross sample must be reduced in size to obtain a laboratory sample.
Alright, now let's see application of solid sampling in agriculture. First is to measure the nutrients that are left in your field following harvest. Soil or solid sampling helps farmers evaluate nutrient levels after harvesting crops, determining essential nutrients like nitrogen, phosphorus, potassium, and micronutrient, enabling better understanding of nutrient reserve for the future growth. Second is to tell you which nutrients are lacking or in excess throughout the soil in a field. Soil sampling helps farmers identify nutrients deficiencies and excess, enabling them to identify crop growth and productivity issues. It also detects excessive nutrients level, potentially leading to environmental concern and corrective measures. So for the third one is to help you determine the most favorable fertilizer plan to increase or maintain yield for the following year. Soil sampling data helps farmers develop tailored fertilizer plans, addressing nutrients deficiencies and optimizing management. This leads to improved crop health, increased productivity, and cost-effective nutrient management. Now, I will explain methodology of sampling in agriculture. The first one is grid sampling. Grid sampling should be used when there is a little information available about the variation in nutrient level across a field. Grid sampling may be useful in fields where variability is expected but the field history is not well known. Topography is uniform but differences in soil type occur. Varied management patterns have been used in the past or many applications have occurred. Proper grid sampling make it possible to identify variation within a field and is an important data layer when determining future management zones for fertilizer application. So next methodology is zone sampling. Zone sampling involves dividing the field into zones that are uniform enough to be managed as a whole and then sampling to determine the average soil test values for those zones. The zone sampling relies on the amount of quality of the data used to determine the zones. Layers such as soil maps, aerial photos, yield maps, topography maps, management history, and personal field experience can provide valuable information about the variation in a field. This information can be used to define sample zones or management zones in a field. As the number of management zones in a field increase, the number of samples need increase. If only a few zones exist, samples can be combined to reduce the cost of analytical expenses. What is liquid sampling? Liquid samples tend to be homogeneous and easiest to be sampled. Liquid mixed by diffusion only very slowly and must be shaken to obtain homogeneous mixture. If water sample is taken from the river, then the water sample is collected at surface, middle and at the bottom of the riverbed. So right now, let's see the application of liquid sampling in industry. So for the first one is quality control and analysis. In this, liquid sampling is used to collect representative sample of liquid such as chemicals, pharmaceuticals, food product and beverage for quality control and analysis purposes. This sample can be tested for various parameters including purity, composition, pH, viscosity, density and contaminant. Liquid sampling ensures that the product meets quality standard and regulatory requirement. So for the second one is environmental monitoring. Liquid sampling is employed to assess the quality of water sources, wastewater treatment process and environmental contaminants. Sample collected from lakes, river, groundwater or industrial effluents can be analyzed for parameters such as dissolved oxygen, pH, turbidity, chemicals, pollutant and microbiological contaminant. This monitoring helps ensure compliance with environmental regulation and guides remediation efforts. Alright, for the last one or the third one is food and beverage industry. So liquid sampling is extensively utilized in the food and beverage industry for quality assurance and product testing. Sample of raw material, which is ingredient, and finished product are collected for sensory evaluation, chemical analysis and microbiological testing, and also compliance with food safety regulation. Liquid sampling ensures the safety, authenticity, and consistency of food and beverage product.
Now, we will see methodology of liquid sampling in industry. The first one is automatic sampling. In some industrial processes, automatic sampling systems are used to collect liquid sample at predetermined interval or based on specific trigger or condition. The second one is sub-sampling. Sub-sampling involves taking a smaller portion or aliquot from a larger collected sample to facilitate further analysis. So this is our reference for this video presentation. We hope you like our video and thanks for watching.